All right, factoring review, question 2A. It's really just more of the same. Just factor each of the following, just new page. Okay, so we take a look at the first question here, and again, the very first thing I need to ask myself is there anything common between those two terms? That should always be the first thing I'm looking for. And I see there's two terms here, so I look at the coefficients. I've got 4 and 16. Well, yeah, there is a common factor of 4 to those. Okay, this is 4 times 1, this is 4 times 4. Then I look at the variables here, and I got x squared in the first term and y to the 8th in the second term. Okay, well, there's nothing common between those two. So what I'm going to be left with here, okay, again, with common factoring, it's about distribution. So I'm saying that that 4 was distributed to two terms. That would have been x squared, to get 4x squared, and then minus 4y to the 8th. Okay, so when I distribute that 4 through, I'm going to go right back to the original. So this is really just restating that original equation just as a product as opposed to a difference here. Now, I can't move on. I shouldn't move on until I investigate what I just pulled out. Okay, and I was left with an x squared minus a 4y to the 8th. So this is a difference of two terms. So I'm just going to see, are these squares here? Well, x squared, yeah, that definitely is. 4 is a perfect square. Is y to the 8th a perfect square? Well, yeah. If the exponent here is even, then yeah, what you're looking at here is a perfect square. So this is going to end up becoming a binomial. This is a difference of squares here. This will be x, minus, plus. The square root of 4 is 2. It'll be y here. Now, I got to think, what's the exponent? If I multiply y by y, what number, okay, when I add it to itself gets 8? And the answer is y to the 4, y to the 4. Okay, just basically I'm just going to divide that by 2. And there you go. And so you should be looking at this and say, okay, could this be broken down any further? Okay, now this one can't because it's a sum of two terms here. That I couldn't simplify. But this one, well, it's a difference. Are these two squares? And no, they're not. So that is as far as you can go.